Hello. Today we're going to be speaking and talking about basic chemistry and the chemistry of organic molecules. This is our first lesson, doing a flipped classroom, so I'm going to take some time and teach you guys a couple things about what to expect and what to do. So if you look up top here, we have our objectives. The objectives should change almost every slide, maybe not, depends on what we're talking about, but that will kind of focus what you need to learn. So make sure that you can answer those questions after every slide. So the first slide is chemical elements. A lot of this stuff is review from chemistry. Atoms are made up of protons, which are positively charged, neutrons are neutrally charged, and electrons are negatively charged. So when we have a neutral atom, like anyone on the periodic table, so say oxygen number 8, it has the same amount of electrons and protons, and that atomic number of 8 tells you how many electrons and protons you have. So that 8 stands for 8 protons, stands for 8 electrons when it's neutral. An atom that has more than one shell, meaning it's something more than hydrogen and helium, has to follow something called the octet rule. So this octet rule is where an atom wants to make sure that it gets at least 8 electrons on the most outside outer shell. It wants to be like a noble gas. In chemistry, that wouldn't fly, saying it wants to be like a noble gas, but that's how we can think about it in biochemistry, is these atoms kind of want to be like helium. It wants to be like neon. It's kind of like a nerd wanting to be like a popular child. So oxygen has 8 electrons total. The first 2 electrons go in the inner shell, 6 electrons in the outer shell. Now, it's kind of hard to remember how many go in inner shell, outer shell. There is a way to remember it, but for our sakes right now in biochemistry, just count how many away it is from the noble gases, which is family number 18 on the far right. So oxygen is 2 away, meaning that it wants 2 more electrons to get to 8. So carbon is 4 away, so it can either lose 4 electrons or it can gain 4 electrons. Nitrogen is 3 away, so it can either gain 3 electrons or lose 5. Now in the case where one side is less than the other, so nitrogen can gain 3 electrons, it always goes with the less. It's a lot easier to gain 3 electrons than it is to lose 5 electrons. You can't just lose them as in like just drop them off. You actually have to give them away. And fluoride just wants to get 1 electron. So this kind of predicts what an atom is going to do, and it completely predicts how it's going to bond. Like oxygen is always going to bond to 2 things. It can only make 2 bonds because a bond is basically sharing of electrons. We'll talk about the next couple slides. So these kind of different bonds, we have 2 different ones. We have ionic bonding, which is strong attraction between negatively and positively charged ions. So these are, we're dealing with charges here, a positive and a negative. And as you guys should know from all your experiences, positive and negative attract. So something like sodium wants to give away an electron to get to neon, and chlorine wants to get an electron to be like argon. They kind of do that with each other. Chlorine gets an electron from sodium, sodium gives it away, makes sodium positive, makes chlorine negative, and they're kind of stuck together since one's positive, one's negative. So that's how we get table salt. A covalent bond is 2 atoms that share electrons, so they're actually sharing back and forth. Now there's 2 kinds of covalent bonds. One kind of covalent bond is a polar covalent bond, and this is when 2 atoms do not share equally. So an example of this is actually water. Water is a polar substance. It associates with only other polar substances. Polar substances is when one atom is basically a bully. Oxygen is a bully. It doesn't like sharing. So it's going to try to hold those electrons tight, close to it, instead of trying to share it with hydrogen. Hydrogen gets the electrons maybe like once a week, if that. So that makes the hydrogens positive by nature in the atom or the molecule, and oxygen will be negative. And that'll come in effect when we talk about water and chemistry in class. Non-polar covalent bonds are 2 atoms that share equally with each other. So they don't fight with each other, they share the electrons equally. It'd be like 2 carbons sharing with each other. We'll go over the chemistry of water in class, so you don't have to worry about that right now. So let's get into organic molecules, since we're dealing with biology here. Organic molecules are things that make up living things. To be more detailed, it's a molecule containing both carbon and hydrogen. That's really the more accurate definition of an organic molecule. Biomolecules are organic compounds that make up all the living things, but there's four main classes. 99.9% of the biomolecules fit into these four. That is carbohydrates, lipids, proteins, and nucleic acids. Now, since there's only four classes, you would think that there wasn't much diversity, but that's not true. There's different kinds of each one of these, and there's thousands and millions of different kinds of carbohydrates. There's different kinds of proteins, so they're very diverse. Now on the right here we have glucose. You guys learn about glucose in regular biology. Hopefully you remember the formula maybe. It's C6H12O6, and you can go ahead and count all those, and that's how it works out. And that's what it looks like in nature. So carbon's actually a pretty cool element. Like I said earlier, it wants to make four bonds to try to become like neon. Now, carbon can actually bond with itself, or with other carbons I should say. While a lot of elements can do that, carbon has a very, very stable bond to other carbons. And this allows it to create long chains, and that's how we get things like lipids and whatnot. Double and triple bonds are possible. The only issue with those is they're a little bit less flexible. Carbons can create rings, like glucose on the right there. And they connect the functional groups to create more diverse molecules. Now, functional groups are very, very important because this is how they kind of get their diversity. Carbons are quite boring. If carbon has four bonds, it's happy. It's never going to react. But the functional groups are the things that are connected to this carbon skeleton that kind of give the carbon its different properties, its elements, its kind of like its personality. So these on the right here, or these group on the right side, not just four, there's tons of them. There's about 30 different functional groups. We have things like alcohol, aminos, ketones. These all have different properties that maintain and stay the same. So when someone tells me there's an alcohol on a carbon group, I kind of know how alcohol is going to react. Now, how we get organic molecules is by two processes. One's by dehydration synthesis. That's how we create them, and hydrolysis is how we kind of destroy them. Now, biomolecules are made up of two things. A large biomolecule is called a polymer. They're made up of smaller units called monomers. Now, hopefully you know poly, like a polygon. Poly means many. Mono means one. So a bunch of monomers make a polymer. And it's kind of like a polymer is like a train, and a monomer is kind of like a train car. Now, each one of these biomolecules has a different kind of monomer, and they kind of form together to make the bigger polymers, or what they're making. Now, when we're creating biomolecules, we're doing that dehydration synthesis. Now, you guys know dehydration means loss of water, or you don't have water. Synthesis, you know that hopefully it means create. So when you get two monomers together, they actually pull off an H on one end and an OH on the other end. That makes water. Water is HOH, or H2O. And that kind of forms them together. That makes them synthesize together. Now, the degradation of biomolecules is by hydrolysis. You add water in, and it kind of separates and breaks the bonds and adds an H on one end to one of the monomers and an OH to the other end. So to kind of review that again one more time, just to make sure you got it, because this is important. And we're going to do this in class. We're going to practice this in class. Dehydration synthesis. You're going to be taking water out of the polymer, or the monomers, excuse me, to make a polymer. And hydrolysis, you're adding water into a polymer to make two monomers. Now, both these reactions just don't happen by themselves. They need an enzyme to react. Now, an enzyme is a molecule that speeds a reaction by bringing the reactants together. So a good way to think about this is if two people don't like each other, they usually won't hang out with each other, they won't be around each other, so they won't react. An enzyme would be if, like myself, I would be an enzyme if I took those two people and put them in a small room with each other and forced them to react and to deal with their issues or to fight or whatever they're going to do. That's how an enzyme does it. They bring in these things close together, then the reaction will happen faster instead of just by chance. So that's all we really have for this lesson. It's kind of a longer lesson, I'm sorry. They usually be a little bit shorter than this. We're going to have a test September 16th. The top 7 things right there, those are questions you need to be able to answer. Those are things you need to be able to know for this section. If you know those things, you got this PowerPoint pretty well done. If you need to go back, go ahead and go back. From someone that's taken a class like this where it was all online with PowerPoints narrated, make sure that you stop and you write down notes and you restart again. You don't just have to keep this playing the whole time. You can start and stop. You can do this over a course of a couple days, whatever works for you. The chemistry water stuff, we'll go over that in class. And I hope you enjoyed your first lesson. Thank you for listening. I'll see you in class.